Okay, so there are two messages on the emissions. It should be a faster, immediate carbon dioxide emission. So we have to begin now and urgently and with deep cuts. So that means if we reduce at once, as early as 2020, the decline to reach net zero is earlier also. So we can meet the requirement of the Paris Agreement. And that net zero can be reached. If it is late, we will reach it by 2055, but if it is immediate, it's 2040. Net zero means that the amount we emit in the atmosphere is also equal to the amount that we absorb. So it is net zero. But it doesn't mean that we cannot go on with other activities. And the cumulative carbon dioxide for in terms of billion tons, carbon dioxide is around 2,005 billion tons globally. So this is the non-carbon dioxide radiative forcing, and it should be also reduced. If it is not reduced after 2030, then we will have this pattern. But if it is reduced immediately, we will have, if it is not reduced at 2030, we will have this pattern. But if it is reduced within 2030, we will have a lower amount. So it will help us meet the target under the Paris Agreement. At 1.0 Celsius, we are already experiencing impacts. That was the message earlier by previous speakers. But at 1.5, if we compare to 2 degrees, there will be less extreme weather where people live, including extreme heat and rainfall. By 2100, global mean sea level will be around 10 centimeters lower, but may continue to rise for centuries. Unfortunately, sea level rise, even if we make our emissions zero, will still continue to rise, but at a lower rate. It is because we are already committed to past emissions. We cannot, that means that even if we completely stop using anything that will give off carbon dioxide emissions, the sea will still rise accordingly. And then, if 1.5 degrees Celsius is maintained, 10 million fewer people will be exposed to this risk. And then lower impacts on biodiversity and species, small reduction in terms of yields of maize, rice, and wheat. This is very important for countries like Thailand and most countries in Southeast Asia where we produce rice. Apparently, or scientifically, it was proven that during nighttime, the rice grains fill. That's the time they fill in the grains. So if we increase the temperature for every degree, we will have a 10% lowering in production. That's what the finding of Erie was. No? Global population exposed to increased water shortages will be 50% less if we keep the temperature at 1.5 warming. Again, there will be lower risk to fisheries and livelihoods that depend on them. This is because some critical ecosystems like coral reefs will already be damaged at 1 degree. And relatively at 1.5, coral reefs might not survive. And as we know, coral reefs are the breeding places of most of the fishes. Up to several hundred million fewer people will be exposed to climate-related risk and susceptible to poverty by 2050, because the livelihoods, if we lost the livelihoods, the poverty will also be higher. These are the so-called RFC, or the reasons for concerns. There were 5 reasons for concerns that the IPCC has established as a framework to express the risks and impacts of increasing the temperature. First is about the unique and threatened systems, and that includes the coral reefs that I was mentioning earlier. It also includes other systems that, for reasons of geographical limitation, intimacity, they can no longer move away from their places, and so they might suffer extinction, for example. RFC2 are extreme weather events. Most likely it's about heat, because global temperature increase is synonymous also to heat waves and increases in the temperature. But it is also about other extreme events. It might be rapid, like tropical cyclones, or they may be slow onset events like drought and wildfires. RFC3, distribution of impacts. Not all places, not all groups have same vulnerabilities, because there are different they are exposed to different hazards. They have their own different vulnerabilities. So the distribution of impacts will not be the same. Global aggregate impacts will have to do with the global monetary impacts on the economy, which is also affected by the changes in the climate. Large-scale singular events are events that will be irreversible, like, for example, deglaciation of the Arctic and Antarctic glaciers. So you can see that the colors changes from this light to darker shade as you increase the temperature from 1 degree. Here, at 1 degree, which is today, currently we have already experienced some effects on RFCs 1 and also for extreme weather events. But the distribution of impacts will be more likely heightened when we reach 1.5, same with the global aggregate impacts. And here the large-scale impacts is already happening, such as the melting of the glaciers, and will become more serious as we move up. This is the scale of the temperature increase from 0, the pre-industrial time, 1 degree, which is current, and the 1.5 and 2 degrees. Just to illustrate the confidence level, for warm water corals, we can see that there are already impacts. If we compare, for example, mangroves with corals, mangroves are more resistant because the impacts, although currently they might not look to be affected, but at 1.5, there are impacts that will be observed. Same with small-scale low-latitude fisheries, because these two are tied together. Arctic region, we already have some observations here. For terrestrial ecosystems, forests, the medium impacts will be, or the high impacts will happen at 1.5. Coastal flooding is already apparent even in this low temperature increase. Fluvial flooding will be heightened at 1.5. Crop yields are already affected. Tourism, most likely the sandy beaches will be lost because of the sea level rise. And then heat-related morbidity and mortality. Just this year, we have seen the heat waves in Japan. So how do we keep the temperature increase at 1.5? There were some emission pathways that are consistent to 1.5 global warming modeled by the special report. This is to limit the warming at 1.5. Carbon dioxide emission should be reduced of about 45% of the 2010 level. So we have to look at the inventory at 2010, and it should be reduced by 45%. If we compare that to 2 degrees, help. Okay. I think life will be easy if we just switch on and off. If we have problem, we switch off. And okay, sorry about that. So compared with 2 degrees, we only need to reduce by 20%. But that is not safe. That's what the finding is. To limit warming to 1.5, we need to, that emission would need to reach net zero around 2050 and compared to 2075 for 2 degrees. And reducing non-carbon dioxide would directly have impacts to health. If we reduce the air pollutants, that will also help to lower the warming, but the benefit is more directly important to our health. Clean air is better for our health. Limiting warming to 1.5 would require changes in social and economic sense. Deep emissions, not only for energy and transportation sector, but it has to be done in all sectors. We can use a range of clean and environmentally friendly technologies. This also will require behavioral changes, a change of mindset, or what we call paradigm shift. And for the government and private sectors to increase investment in low carbon options. Progress in renewables would need to be mirrored in other sectors. For example, in agriculture, if they use pump, for example, to pump water for irrigation, they may use renewables in order to mitigate the carbon dioxide emission. We would need to start taking carbon dioxide out of the atmosphere. So the traditional and more conventional mitigation involves reduction and avoiding emissions. But there will still be remaining carbon emission in the atmosphere. And for that, we need techniques or technologies to be able to remove those emissions. And this has implication for food security, ecosystems, and biodiversity. Therefore, the use of technologies will differ from place to place. It has to be contextualized on what the needs, on the national circumstances of the countries that will use these technologies. The national pledges, which are written in the country's nationally determined NDCs, nationally determined contribution. It's not commitment, it's contribution. Sad to say, will not be enough to address the 1.5 warming. We are committed, as is, we are committed to around 3 to 4 degrees warming. So avoiding warming of more than 1.5 would require carbon emissions to decline substantially before 2030. So these are the graphs in the special report that illustrate the model pathways. So in the report, we mention the word overshoot. It will not be possible to pinpoint the exact time that 1.5 will be reached and that we cannot keep the 1.5 stable at one point. Therefore, it will offshoot. So it will overshoot that line. But we have to keep this at a very low or minimum overshoot of 1.6. Because if the temperature increase is more than 1.6, it might go back to 1.5, but the impacts on some of the ecosystems may be irreversible. For example, again, the coral reefs. When the temperature increase hit 1.5, there will be damage, completely damaging to the coral reefs. Even if we go back to 1.5 or 1 degree, it's not possible to recover all of these ecosystems. And some of the species, for example, tree species, particularly those that are endemic, those that cannot move away from a certain location, will be affected. Here also are shown the non-carbon dioxide emission, which we also call black carbon. So there are countries that have high pollution level, and this, on the short term, they have also a high global warming potential. So these are also included in the computation. So there are several pathways that are indicated here, and the timing of net zero carbon dioxide is statistically determined for different scenarios. So if you want to have more details, I would recommend for you to read chapter 2 of the full report. Chapter 1 is about frame and context, but chapter 2 provides the mitigation pathway. So they describe more details about these different pathways. This one is about high overshoot potential, this gray area. That means 1.6 or greater warming. Okay, it's the same. Let me just go to these characteristics of these 4 illustrative model pathways. There are different mitigation strategies that will require to follow a pathway that will not overshoot or will only have a minimal or limited overshoot. And this involve carbon dioxide removal techniques. Or if this cannot be done alone, this can be coupled with some bioenergy, with carbon capture and storage, and removals in agriculture, forestry, and under land use. Specifically, this last topic is very critical and also, I should say, contentious because Southeast Asia is a largely agricultural country, economy, but and we don't want to do mitigation because this might affect food security. So the scenario for Thailand and for the Philippines are very much the same. The sector doesn't want to include the agriculture into the NDCs or the determined contribution for mitigation. But there are some ways to do this without compromising the productivity of the sector. This has implication for the emission and several other pathway characteristics. So the first scenario, in which there are social, business, and technological innovation, result in lower energy demand. So when we say demand, it's not only the supply side which will mitigate, but it is also the users. No? The users will have to change their ways of using energy. There is a downsized energy system which will enable rapid decarbonization. And the only technique here is afforestation. Afforestation is the creation of forest when there was none before. So there is a large potential for urban setting to create green spaces, to create these areas where you plant trees and to be able to contribute to the reduction of emission or absorption, I should say. Neither fossil fuel with CCS, with carbon capture, or the BECCS are used. So this is a very clean approach. Scenario 2 has a broad focus on sustainability, which include energy intensity, human development, economic convergence, etc. So this one has a higher ambition than this one. Okay, so there is also international cooperation as well as shifts towards sustainable and healthy consumption patterns. So again, the providers are not the only ones to do the mitigation. It's not only the government to do the mitigation, but also the communities, also the other demand side sectors. P3, the third scenario is a middle of the road scenario in which society as well as technology follows historical patterns. Emission reductions are mainly achieved by changing the ways which energy and products are produced. So this part has a greater effort for the providers and the government to do the mitigation. The supply side has to do, for example, in transport, probably there's a shift more towards mass transport instead of individual through policy and government laws. That would be the enabling environment. P4 is a resource and energy intensive scenario, so you don't control your development, and it leads to widespread adoption of greenhouse gas intensive lifestyle. including high demand for transportation. So therefore, emission reductions are mainly achieved through technological means, making strong use of the technologies. So this scenario, we just go about our own ways, the way we do it now, but it will require the use of more absorptive what we call carbon reduction technologies. There are some discussion, but these are not recommended in the special report. There are some mention of solar radiation management techniques, but these are not recommended. Again, I would say that all the things discussed in the special report are just IPCC provide information for the government, but it is up to the government to select. They have the option to select what is good for the country. IPCC has already created this global trend indicator to see if the reduction is being done. So some of these look at the reduction in temperature and emission. Some of these indicators look at energy systems, like energy efficiency and reduction in the use of energy. Some of these also indicate how carbon dioxide are removed through technologies, and around 3 of these are for agriculture sector. For example, land area of bioenergy crops in 2050, reduction in the methane emissions, and agricultural nitrous oxide emission. I think this has to do with the use of fertilizers. So maybe there will be some balance between organic and inorganic sources. So all of these are provided, more details are provided in chapter 2 of the full report. Some of these are agreed in principle in the Kyoto Protocol, gas emission based on the new guideline. And changes in energy demand are associated an improvement in energy efficiency. So this one is on energy system. So energy efficiency is also counted. As I already indicated, this report notes that the effectiveness of some of the techniques are unproven at large scale. Commercially applying this to large scale may be risky, and therefore countries should take precaution in applying, because they may carry significant risk for sustainable development. For example, the use of large portion of the area which will replace food production specifically. So food security might be compromised. So these have to be balanced in your studies or research work. There is also a chapter 4 and 5 look at the strengthening of the global response in the context of other international agreements, specifically the Sustainable Development Goals and eradication of poverty. There are mix of measures to adapt to climate change and reduce emissions as well. So for example, in the mangrove reforestation, rehabilitation, You can also improve fisheries. It can also